Alright, here you have a reflected light with of phase difference pi radian. That means these two reflected light, wave 1 and wave 2, they have phase difference pi radian. That means they are anti-phase. What it means is these two wave pi minus 0. So the difference, the phase difference in between these two wave is pi radian. We can say pi minus 0 equal to pi radian lah. Okay. So what makes them anti-phase? It's all because of the phase change. Phase change, again, phase change only happen during reflection from lower to higher refractive index. Lower to higher refractive index. So phase change only happen on this occasion. So let's look at, investigate what makes these two wave anti-phase. Okay, again, what I can say, these two wave, they originate from the same source. Okay, so same color, same wavelength. Okay, if this is a blue light, these two light also blue light because they originate from the same source. The same case as last time I talked about the in phase. Okay, however, phase change, the phase change that makes these two wave become anti-phase. Why I say like that? Look at here. Okay, let us first investigate the first wave. Yeah, again, this wave actually come incident, normal. Yeah, it come in normally. It's not coming at an angle. It come actually at an normal. Okay. Now I just want to let you learn why these two waves are anti-phase. Okay. First of all, let's look at the first wave. Okay, the first wave. Maybe I'll use a highlighter. Okay. Now the first wave, the light comes from the air. Okay, maybe yeah, we can say this. First of all, I can say this example is you see the refractive index low is a low refractive index, and then go higher, and then this one back to low again. You see that? Compared to before is low higher highest, low higher highest. This time is low higher back to low. That's the difference. So it is like the soap bubble. This thing is like the soap bubble. Outside is like air. You see, outside of the soap bubble is air, and then the soap itself, the bubble itself is actually the soap film. We can say it is a soap film. The soap film, you know, the sphere, the soap film, and then inside the soap bubble is air again. Okay, so this one is like a soap bubble. Air, low, higher, low refractive index. Yeah, the soap film is the bubble itself lah. Inside the bubble is air. Okay, so now here, yeah. Also, you can see different color. You can see blue, you can see yellow, red, violet. Okay, because of different thickness. Of the just like the oil film, because they have different thickness, they form different wavelength of color, of reflected light. Yeah, from bright fringe for different wavelength at different thickness. Yeah, from bright fringe for different wavelength for different thickness. So we can say, although this soap bubble looks perfectly sphere, however the soap film is actually uneven. Yeah, it is actually uneven thickness. It's actually uneven thickness. The film, because you know the fluid is always flowing here and there. Yeah, fluid is not fixed like ice. Yeah, the fluid always flow here and there. The water can flow. The soap film can flow from one part to another part. That's why you can see the thickness always changing. You can see the color on the soap bubble. Always changing, yeah, different colors. Sometimes become red, sometimes become pink, blue, like that, yeah. So when you almost like want to explode, you already become like blue color, violet color. Violet means it's become very thin already. Yeah, when it's becoming violet means the smallest wavelength, it become very thin. When it become almost like, if you see red color means it's still, the bubble is still very thick. Yeah, it won't explode. But when you see the bubble almost become like purple color, blue color, purple color, you can see it almost explode already. It almost explode because the thickness is very thin already. Yeah, the bubble already become very thin. When very thin, it almost explode. Okay, so you can see the bubble has different color. Okay, now I want to talk about the antiphase. So the antiphase, why makes these two wave become antiphase? So first of all, look at the first wave. Look at the first wave. So you see the first wave. This is the incident. Okay, this is the incident light. It's the incident light. You see here, the first light comes and then reflect. You see reflection. Reflection from lower to higher refractive index. From lower to higher refractive index. Reflection. Got any phase change? Yes, got phase change pi radian. So the first light has one time phase change because it meet a hard surface. Because it's from air go to soap with higher refractive index. So this reflection is like it encounter a hard surface here, a fixed end here, cannot vibrate. So here got a phase change. So the first wave encounter one time phase change pi radian. Alright, okay. So I can draw like that. I can draw. Okay, I can draw two wave like that. Okay, draw two wave like that. Okay. This is the first. Okay, let me draw it out. This is the first wave and this is the second wave. Okay, the first light, it comes. Okay, like that. It comes. The second light also the same. Okay. Now, however, for the first light, it encounter one time phase change from reflection from air to soap. That means from lower to higher refractive index, reflection. Got one time phase change pi radian. So got phase change, got one time phase change of pi radian. So got phase change. The first light got phase change pi radian. That means it invert lah. It actually should go up, but because of phase change, it go down. It go down, yeah. Remember, initially it should actually go up, no phase change, but because of phase change, it go down. It go down lah. It go down. Got phase change of pi radian. Understand? Phase change. One time phase change. One time phase change. This one got one time phase change pi radian. Okay. One time phase change. Now, how about the second light? How about the second light? The second light, yeah. Let us just rub this off. Now, the second light, I can use the, maybe I can use again, sorry. I can use the blue color lah. Okay. Now, you look at here. The second light, let's look at the second light. The second light comes. Okay, enter the second surface. Enter. Is there any phase change when entering? Refraction. Got any phase change? No phase change. No phase change, but you see here reflected. Here it reflected. Here it reflected. However, this reflection is from higher to lower refractive index. Higher to lower refractive index, reflection got phase change? No phase change. Remember, phase change only happen for reflection from lower to higher, not from higher to lower refractive index. Remember, it's from lower to higher refractive index. The one higher to lower refractive index, like this one, the reflection from higher to lower refractive index, no phase change. Phase change only happen from lower to higher. From higher to lower, no phase change. The reflection, no phase change. Okay, so look at here. So this part, no phase change. That's why I don't circle it. I don't circle it because no phase change. Okay, so all this while, is there any phase change? No. Along this path, no phase change for the second wave. Second wave, no phase change. This reflection also no phase change. Okay, and then it goes out. It goes out here. Yeah, it goes out. Got phase change when it goes out. Got any phase change when it goes out from soap to air? Refraction. Got phase change? No phase change also. So all along the way for second light, all along the way, entering from air to soap, no phase change. Reflection from soap to air, reflection, no phase change. Soap to air, reflection, no phase change. So no phase change along the journey. 0. I put as 0. So what I can say is the first light got phase change of pi radian, but the second light no phase change at all. So what's the phase difference between them? So the first light got phase change of pi radian, but the second light, yeah, this is the second light. The second light no phase change at all, so 0. So pi minus 0, pi radian. So between the wave 1 and wave 2 has the phase difference of pi radian. Has a phase difference of pi radian because pi minus 0 is pi. Yeah. What I can say is pi minus, so this is the phase difference. Pi minus 0 equal to pi radian. In between them, this is the phase difference between them. Okay. Or in other words, you can look at here. Look at this diagram. The wave 1 just now has one time phase change, pi radian, isn't it? So it invert below. Now for the second wave, yeah, it comes from the same source. For second wave, no phase change at all. No phase change. So that means it's still maintained. It's still maintained. Yeah. Second wave. Okay. Let me rub this off. Yeah. Wait. Let me just drag this over. Drag this over. Okay. Drag this over. Yeah. Like that. Yeah. Okay. Now, let's look at this diagram. Yeah, let's look at this diagram. Just now the wave 1 has one time phase change, go below already. Now how about the second wave? Second wave, all along the way, no phase change at all. So that means the wave, it maintained no phase change. The second wave has no phase change. We put as 0 radian. So no phase change at all. That means it maintained going up lah. Maintain going up. Do you see that? So what is the result? What is the result? These two waves become anti-phase. They become anti-phase. You see that? The wave 1 is going below, but the wave 2 become going above. Become anti-phase already because only one of the wave has phase change. So they become in the beginning here become anti-phase already. So it become anti-phase. They become anti-phase sources. That's why these two sources become anti-phase. Understand or not? Unlike last time, both wave encounter one time phase change. Wave 1 got phase change. Wave 2 also got phase change. So both also invert. Both invert until they become in phase. But yeah, because this one both wave got phase change, so they end up become in phase. But this one, only one of the wave got phase change. The other no phase change. So they become anti-phase. That's why they become anti-phase. Okay? That's it. That is it. So that is what makes this. We have thin film. We have two category. Thin film. We have two category. The first category is in phase, and then the second category is anti-phase. So that is because of this. The first one is because like lower, higher, highest refractive index. This one is because lower, higher, lower refractive index. That what makes all these in phase and anti-phase category. So for anti-phase category, let's remember about the anti-phase category. For anti-phase category, look at this one. For anti-phase category, this one, you see that? Anti-phase category, for the bright fringe, the delta M is M plus half lambda. The dark fringe is M lambda. So it's like in opposite from the in phase one, opposite. So the M lambda used to be bright fringe, now become for dark fringe. The M plus half lambda used to be for dark fringe, now become the bright fringe formula. That's for anti-phase. They become invert. So you can see, okay, anti-phase, bright fringe is using M plus half lambda. Bright fringe use M plus half lambda. Is it correct? The anti-phase one, anti-phase, the bright fringe use M plus half lambda. That's correct. And then for the dark fringe use M lambda. Is it correct? Yes, the dark fringe use M lambda. You see that? So the same thing lah. Actually, you can see these two formula in phase. In phase is the formula is 2nt equal to m lambda, 2nt equal to m plus half lambda. Anti-phase just invert them. Become m plus half lambda become for bright fringe, m lambda used for dark fringe. The formula is still the same. Yeah, you see, 2nt m lambda, m plus half lambda, and then invert become here bright fringe use m plus half lambda. This one m lambda. The formula still 2nt, still the same. Okay. This is it. Now about the thickness again. This one also the same lah. As long as you have a half lambda there, as long as you have a half lambda there, the m you can safely put 0. M you can safely put 0. But if there is no half lambda, you cannot put m equal to 0, because if you put m equal to 0, the thickness will become 0, which is what I can say impossible to happen. Because we know that if you put if you have 0 thickness of thin film, means there's no soap bubble at all. There is no soap film at all, no soap bubble at all, because the 0 thickness of film. 0 thickness of film means no film, no soap film. So for this one m lambda, I cannot put m equal to 0 because it will make thickness equal to 0. So for this one, the minimum order is equal to 1. So the same thing, the question will ask about the what? About the maximum, so about the maximum wavelength and minimum thickness. Whenever you have the m lambda, make sure you put m equal to 1. If you have m plus half lambda, you put m equal to 0 to find the minimum thickness or maximum wavelength. Okay, so for this one also the same lah. Also the same. Or if the question asks for minimum thickness, like for the dark fringe minimum thickness, this one m you put equal to 1. For this one bright fringe, the question asks for minimum thickness, this one m you can put 0. Okay, or maybe the question will ask for maximum wavelength. So it's how you change the equation. Okay, I have explained everything. Now one more thing is this n. Remember, you have many refractive index here. You see this n. Remember, you use the thin film. You use the n for thin film. Don't use the n for other medium. Like only use the refractive index of the thin film, the middle layer. The middle. I can say is the middle layer. Middle layer. Not the other layer. Always the middle layer, not the bottom layer. The thickness also take the thickness of the soap film. So like you see this one, the oil. Okay, you see the refractive index. Take the oil. You must take don't take this refractive index. Don't take the refractive index of the water. Take the refractive index of the thin film. The middle layer. So the thickness also take the thickness of the thin film. Okay, take the middle layer. Don't take the water layer. Okay. So yeah, that is it. Yeah. And sometimes we have that is it lah. Okay. So yeah. Now proceed to the next video. Thank you.